This is part 2 of a review of trig equations and inequalities, the tangent function, and inverse trig functions. These are AP Precalculus topics 3.8 through 3.10. If you appreciate the content, please give it a like. Number 4. The figure above shows a circle centered at the origin with an angle of measure theta radians in standard position. The terminal ray of the angle intersects the circle at point P. If tangent theta equals 5/12, what is the slope of the line that passes through the origin and P? The tangent function gives the slope of the terminal side. So, since we are told that the tangent of theta is 5/12, that means the slope of this line is 5/12. So the answer is simply C. Number 5. Which of the following is the graph of f of x equals 2 times arcsine? Quick side lesson. F inverse is the inverse of function f. If the domain of the original function is a to b and the range is c to d, then the domain and range of the inverse function will be the reverse of this. So the domain of the inverse function will be the interval from c to d, and the range will be the interval from a to b. Sin x and arcsine x are inverse functions, so the domain and range of sin x should be reversed when compared to the domain and range of arcsine. We know that the range of sin x goes from a low of -1 to a high value of +1. Therefore, the domain of arcsine should be the interval from -1 to +1. We know the range of arcsine based on a set of memorized range restrictions. If you have not yet memorized the range restrictions for arcsine, arccosine, and arctangent, pause the video and memorize them right now. But for now, we need to know that the arcsine function is restricted to a range of -π/2 to +π/2. So here's the domain and range of arcsine. We can use this to choose the graph, but be careful. F of x is actually a slight transformation of arcsine. It's 2 times arcsine. That's a vertical dilation by a factor of 2. A vertical dilation is only going to affect the range, not the domain. So we need to multiply these range values by 2. Multiplying both of these by 2 is just going to wipe out the denominator. So we're going to end up with just -π and +π. So we need to look for the graph that has a domain of -1 to 1 and a range of -π to +π. Let's start with the domain. So from left to right, we're looking for a graph that goes from -1 to 1. Let's see, -1 to 1. Okay, A and B both do that. Well, you know what? It looks like all the graphs go from -1 to 1, so that wasn't super helpful. So what about the range, which must go from -π to π? So let's see what we've got there. Option A goes from -π/2 to +π/2. Not quite. Option B goes from 0 to π. Nope. Option C goes from -π to +π. That's the one we were looking for. And just to confirm that somehow option D is not another version that does the same thing, option D, the range is 0 to 2π, so that's a no. The answer is C. Number 6. The function f is given by f of x equals 1 plus 2 tangent x. Which of the following gives the vertical asymptotes of f of x? First of all, a vertical dilation by a factor of 2 does not affect a vertical asymptote. It's just a vertical stretch. That doesn't move a vertical asymptote around. Nor does a vertical translation. So the bottom line is we can ignore the 1 and the 2. We just need to find where tangent x is undefined. And remember, tangent x is sine x over cosine x. The vertical asymptotes will occur where the denominator cosine x is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So x will equal pi over 2 and 3 pi over 2 on the interval from 0 to 2 pi. However, we need an expression representing the infinitely many solutions as we go around and around. Since each solution is pi away from the previous solution, we can get the infinitely many solutions by adding multiples of pi. In other words, by adding pi k, where k is any integer. So that's it. We are looking for pi over 2 plus pi k, where k is any integer, and the answer is A. Number 7 is very similar to number 6. We are looking for the vertical asymptotes of the tangent of x minus pi. So this will again be where the denominator cosine of x minus pi is equal to 0. We begin by solving for the inside expression x minus pi, and cosine will equal 0 at pi over 2, as you've seen several times by now. And I'm not going to draw the picture again. We know that we will get infinitely many solutions by adding multiples of pi, so pi k. We need to algebraically get x by itself, and that means adding pi to both sides. So I need to be very careful here. As I add pi to the other side, I'm going to end up with pi over 2 plus pi k. All right, that's what we already had. And now we're going to have this plus pi on the end. I want to convince you why adding pi on the end is not really changing anything. I will get the exact same values with or without the pi. So I'm going to convince you that the answer is A, pi over 2 plus pi k. Let's evaluate pi over 2 plus pi k for various values of k. Pi over 2 is here at the top of the circle. When k is 0, we are really adding nothing, pi times 0. So we are just left with pi over 2. But when k is 1, then this part is pi. So we have pi over 2 plus pi. That means we start at pi over 2 and we go pi radians further around the circle, and we end up here at the bottom. This is 3 pi over 2. When k is 2, we are adding another pi to this. Pi is 2 pi over 2. So adding another pi to this makes this 5 pi over 2. When k is 3, that's adding another pi. Another 2 pi over 2 makes this 7 pi over 2. And when k is 4, that's adding another pi to this. Another 2 pi over 2 makes this 9 pi over 2. Notice that these expressions are the same, except there's an extra pi being added. So we can find the values of this column by taking the values of the previous column and just adding an extra pi. Remember, pi is equivalent to 2 pi over 2. So we're just adding 2 pi over 2 to each one of these. So pi over 2 plus 2 pi over 2 will be 3 pi over 2. Do you see how this is not a new value? That's a value that we already had on the previous list. And if we add pi again, add 2 pi over 2, this will be 5 pi over 2. Adding pi to this gives us 7 pi over 2. Adding another 2 pi over 2 gives us 9 pi over 2. And adding pi one more time will give us 11 pi over 2. But you can see that these values are not really different. Remember, k goes on forever in both directions, including back to -1, -2, -3, etc. You will find all of the same values with or without the extra pi. So adding the extra pi is not really changing the set. So that's why we can disregard the plus pi on the end of this, and the answer is simply pi over 2 plus pi k, which is a. Number 8, the graph of the function g is given in the xy plane. If g of x is a times the tangent of bx, where a and b are constant, which of the following is true? So we need to figure out whether a is positive or negative, and whether b is greater than 1. So let's start with a. We have learned that the parent function y equals tangent x is always increasing. It forms these waves that are increasing like this. So when we have a transformation of a tangent function, we can see if it's sort of right side up or upside down, whether the waves are increasing or decreasing. So these waves are increasing from left to right, just like the parent function. That means the a value must be positive. If the a value was negative, we would see decreasing waves like this. And we don't. So a is greater than 0, which means we can eliminate options C and D. Now let's find the b value and see if it's greater than 1 or less than 1. The b value can be found using the following formula. For tangent, the b value is pi divided by the period. We can find the period by looking at how far apart these points of inflection are. So we're going from 0 to 2 pi, so the period of g is 2 pi. So the b value is going to be pi divided by the 2 pi. The pi's cancel, and we are left with a b value of 1/2. That is less than 1. So that's why the answer is going to be B and not A. Number 9. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle A is undefined. Which of the following could be the measure of angle theta? If we are talking about a slope that is undefined, we are talking about a vertical line. So that would occur at pi over 2 or 3 pi over 2. So the answer is C. Number 10. In the xy plane, an angle theta is in standard position with a measure of theta equals pi over 6. Which of the following is true? All of the answer choices talk about the slope of the terminal ray, and slope is given by the tangent function. So this is an indirect way of asking which of these is the tangent of pi over 6. And we have memorized that the tangent of pi over 6 is 1 over radical 3. By the way, this is equivalent to radical 3 over 3. But questions like this are why I want you to know both versions. So hopefully you can recognize this as the tangent and thus the slope at pi over 6. So the answer is B. Number 11. The function f is given by f of x equals the tangent of 3x minus 1. The graph of f is mapped to the graph of g in the same xy plane by a vertical dilation of the graph of f by a factor of 4. Which of the following is an expression for g? So let's see. G is a vertical dilation of f by a factor of 4. So that's 4 times f of x. And f of x is right here. So that means g of x is going to be 4 times the tangent of 3x minus 1. I don't see any big parentheses in here, so it looks like we need to do the distributive property. So g of x is going to equal 4 tangent 3x minus 4. So the answer is B. Number 12. The function f is given by f of x equals arcsine x. What input value in the domain of f yields an output value of arc cosine radical 2 over 2? So when they say what input value yields this output value, that's a long way of saying solve the equation where you set the original function equal to this output value. So we need to solve the equation arc sine x is equal to arc cosine of radical 2 over 2. Your first step is to simply evaluate the arc cosine of radical 2 over 2. And the way you do that is first, in your mind, you ask yourself the cosine of what is equal to radical 2 over 2. Paying attention to the restrictions, and the restriction for arc cosine is that it has to be between 0 and pi. We have to remain in this interval for the answer. So keeping that in mind, the cosine of pi over 4 is radical 2 over 2. So that is the value of arc cosine radical 2 over 2. So the equation becomes arc sine x is equal to pi over 4. We need to solve this for x, so somehow we need to make the arc sine go away and just leave x. We can accomplish that by taking the sine of both sides of this equation. So I'm going to do the sine of the left side and the sine of the right side. Sine and arcsine are inverse functions, so if you take the sine of arcsine, those cancel each other out and simply leave x. So on the next step, we will have x equals on the left-hand side. And on the right side, we have the sine of pi over 4. And we have memorized that the sine of pi over 4 is radical 2 over 2. So the answer is D. 13. The function g is given by g of x equals 3 arc cosine 4x. What input value in the domain of g yields an output value of pi? Again, this is an indirect way of saying set g equal to pi and solve. In other words, we need to solve the equation 3 arc cosine of 4x equals pi. We begin by dividing both sides by 3, and we get arc cosine of 4x is equal to pi over 3. We can cancel out the arc cosine with a cosine. So let's take the cosine of both sides of this equation. On the left side, these cancel each other out, leaving the 4x from the inside. And on the right side, we have the cosine of pi over 3. And we have memorized that this value is 1/2. Finally, we simply multiply by 4. So, we're dividing both sides by 4, not multiplying by 4. So we will have x equals, and when you divide a fraction by a number, whatever you are dividing by ends up multiplying into the denominator. So this is 1 over 2 times 4, or 1 over 8. That's why the answer is B. 14. What are all values of theta on the interval from 0 to 2 pi, where cosine squared is equal to negative cosine x? Do not divide both sides of this equation by cosine theta. You will lose a solution if you do that. Instead, let's move this cosine over to the left by adding cosine theta to both sides. that will leave us with cosine squared theta plus cosine theta is equal to 0. We only have two terms here, so the way you factor is to factor out a common factor, a GCF of cosine theta. To figure out what goes inside the parentheses, you divide each of these terms by cosine theta. You can do this in your head. I'm just showing it for instructional purposes. So dividing both of these by cosine theta, the blue cosine theta will cancel out one of these cosine thetas. This is cosine theta times cosine theta. We will be left with cosine theta. And of course, anything divided by itself is 1. We continue by setting each of these factors equal to 0 and solving. Subtracting 1, this factor becomes the cosine of theta equals -1. So where does cosine equal 0? Cosine is the x value on the unit circle, and the x value will equal 0 here and here. So theta will equal pi over 2 or 3 pi over 2 on the interval from 0 to 2 pi. And then, where does cosine equal -1? Well, the x value will be -1 right here on the left-hand side. And that's at pi, so theta is also equal to pi. And that's it. So we are looking for the answer choice that includes all three of these. And the answer is D.
Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.